Heat transfer in the kitchen. In this three-part video, we will explore the different types of heat transfer needed to cook a three-course meal. First, we will start with the appetizer, deviled eggs. Next, we will move on to the entree, steak. Finally, we will finish with dessert, cake. Each course will focus on a heat transfer method. The appetizer will focus on convection. The entree will focus on conduction. And dessert will focus on radiation. Not only will we discuss the types of heat transfer, but the aspects that impact the process, such as thermal diffusivity, thermal conductivity, heat capacity, and absorbance. The videos will focus on the conceptual aspect of heat transfer at a high school level. The purpose is to introduce and/or reinforce the theory of heat transfer by showing an everyday example like cooking. Part 1. Appetizer. We will discuss the heat transfer process known as convection in this video. First, we will give a real-world example of how heat is transferred when boiling eggs. Then we will discuss the different types of convection, natural and forced. Finally, we will finish by discussing heat capacity. Cookware. While boiling the eggs, we will use a stainless steel pot and a gas stove. Convection. When boiling eggs, the main heat transfer process that takes place is convection. Definition. The textbook definition of convection is a transfer of energy between a solid surface and an adjacent fluid that is in motion, and it involves the combined effects of conduction and fluid motion. Heat transfer. When boiling eggs, the heat is transferred to the pot from the stove through conduction. The pot then transfers heat to water. The heat flows through the water by convection. Finally, the heat is transferred from the water to the eggs through convection as well. Natural convection. The textbook definition of natural convection is the fluid motion that is caused by natural forces. One example of this is buoyancy forces that are induced by density differences. Since warm water is less dense than cold water, it will rise while cold water will sink. Forced convection. The textbook definition of forced convection is defined as the fluid is forced to flow over the surface by external means, such as a fan, pump, or the wind. One example of this can be caused by a heater in a house. As the air is warmed by the heater, it rises, and the cooler air sinks. The cooler air is then warmed, and the cycle continues. Heat capacity. The dictionary definition of heat capacity is the amount of heat required to raise the temperature of 1 mole or 1 gram of a substance by 1 degree Celsius without change of phase. Heat capacity is the heat storage capacity of a material. It can be expressed in two different ways. It can be expressed C_P, which is expressed as heat capacity per unit mass. It can also be expressed as C_P multiplied by rho, which is expressed in units of heat capacity per unit volume. Equation. The relation of heat transfer per unit surface through convection is known as Newton's law of cooling. Q is the heat transfer per unit time, and it is measured in watts. H is the heat transfer area of the surface, and it is measured in meters squared. HC is the convective heat transfer coefficient of the process, and it is measured in watts per meter squared Kelvin. Finally, T is the temperature difference between the surface and the bulk fluid, and it is measured in kelvins.